All right, let's dive right in. Today, we are talking all about the human body, and specifically, we're going to uncover this incredible secret principle that keeps everything inside you running smoothly. It's this constant, microscopic balancing act that's happening inside of you, literally right now.
I mean, really think about it for a second. How do you stay you? You know, the world outside is always changing. It's hot, it's cold, you just ate a huge meal, or maybe you haven't eaten in hours. And yet, your internal world, it stays remarkably stable. So, how on earth does your body pull that off? Well, that's the big mystery we are going to unpack today.
Okay, so to get started, we need to get our heads around two really fundamental ideas: anatomy and physiology. The easiest way to think about it is like this: it's the difference between having a car's parts list versus knowing how the engine actually works. So, on one hand, you've got anatomy. This is all about the what and the where. It's the body's blueprint. For instance, knowing the heart has four chambers. That's anatomy. But then, on the other hand, you have physiology. And that's all about the how and the why. It's the physics of it all. How does that heart actually pump blood? So one is the map, and the other is the machine in motion. And here is the most important takeaway, the absolute crucial point. Structure determines function. It makes perfect sense, right? A bone is shaped the way it is so it can bear weight. The walls of the air sacs in your lungs, they're super thin, which is absolutely perfect for letting gases pass through. The two are totally inseparable. The design of every single part of your body is perfectly, and I mean perfectly, tailored for its job. All right, so we have established that the blueprint is directly linked to the job. But how is that blueprint even built in the first place? Well, your body isn't just some random jumble of parts. Oh no, it is a true marvel of organization, constructed layer by layer, with each level getting more and more complex. It all kicks off at the tiniest level, the chemical level, with atoms and molecules. From there, these build cells, the basic units of life. Then those cells team up to form tissues, like muscle tissue. Tissues then come together to create an organ, like your stomach. Those organs don't work alone. They form organ systems, like the entire digestive system. And finally, all those systems working in concert, that creates the complete organism. That's you. It's this really elegant, beautiful hierarchy. So now we're going to see how all of this comes together. Let's circle all the way back to that first question we asked. In a world that's constantly changing, how does your body stay so stable? The answer? Well, it has a name. And honestly, it might just be the single most important concept in all of physiology. And that name is homeostasis. What is it? Simply put, it's your body's number one nonstop mission. It's the ability to keep your internal environment, we're talking temperature, pH, fluid levels, all that stuff, within a really, really narrow and optimal range. It is the absolute core principle of staying in balance. And you experience this all the time without even noticing. When you get too hot, what happens? You sweat. Too cold? You shiver. That's homeostasis in action, just trying to keep your core temperature right where it needs to be. Or think about this. After you eat a candy bar, your body gets to work bringing your blood sugar levels back down to normal. It's this silent, completely automatic, incredible process of just staying in balance. Okay, so if this is happening automatically, how does the body actually do it? I mean, how does it achieve this constant balance? Well, it's not magic, that's for sure. It's a very, very precise control system. The best analogy is to think of it like the thermostat in your house, only, infinitely more sophisticated. The main way it does this is through something called a negative feedback loop. Let's just stick with our body temperature example because it's a great one. So step one, there's a stimulus. Your body temperature rises. Next, receptors. Little sensors in your skin and brain detect that change. They send a message to the control center, which in this case is a part of your brain called the hypothalamus. The hypothalamus then decides, okay, time to act, and it activates the effectors, your sweat glands. And the final response? You sweat, your body temperature goes down, and boom, balance is restored. And this whole process really shows you the core idea perfectly. Why is it called negative feedback? Well, it's because the response, sweating, negates the original stimulus, being too hot. The entire goal is to cancel out that initial change, to shut off the alarm signal, and get you back to that stable set point. It's a system literally designed to reverse changes and bring you back to normal. Okay, so we've got the core operating principle down. Now we need to learn the language that scientists and doctors use to talk about all this stuff. To describe anatomy accurately, you need a common set of directions.
Think of it like a built-in GPS for the human body.
And these terms are actually pretty straightforward once you get them. For example, superior just means toward the head or above. Inferior means away from the head or below. Medial means you're moving toward the body's midline, and lateral means you're moving away from it. What this does is it creates this precise universal language so that no matter how the body is positioned, we can all describe the exact location of any part. The body also has these large internal compartments, or cavities, and their main job is to protect our vital organs. You've got two main ones. The dorsal cavity is on your backside, and it protects the super fragile stuff, the brain and the spinal cord. Then you have the much larger ventral cavity up front, which holds pretty much everything else, your heart, your lungs, your stomach, you name it.
Now, here's a really cool and important detail. Inside that ventral cavity, a lot of the organs are wrapped up in these thin, double-layered sacs called serous membranes. And what these do is produce a slippery fluid. So why should you care? Well, it's all about reducing friction. Think about it. Your heart and lungs are constantly moving, thousands and thousands of times a day. This fluid allows them to do that smoothly without rubbing up against each other or other parts of the body. It's basically a perfect built-in lubrication system.
So, what have we seen today? Your body is an absolute expert at self-regulation, a master of maintaining balance through these incredibly precise control systems. But that brings us to one final and maybe the most important question of all. What happens when it all goes wrong? What happens when these control systems fail and homeostasis breaks down? Well, that failure, that imbalance, is the very definition of disease. And that's why understanding this amazing balancing act is the first and most critical step to understanding what it means to be healthy.